Hey everybody, and welcome to the stream. This is the Shy Hat, and it is December 15th, 2023. It is a Friday, and today we're going to be working on our TryHackMe Advent of Cyber event. So today's challenge is going to be about machine learning. So this is the second day in a row that we've had a machine learning topic, and I'll admit right up front that machine learning is not something that I know particularly too much about, but we're here to learn, and I guess we'll be doing it live. All right, so to everybody who wants to join in with our Advent of Cyber challenges, you can access it through this link that I'm leaving in the chat right now. Of course, you'll need a valid TryHackMe account in order to access this this page, but that's not such a big impediment, and I hope everybody who's interested in learning some beginner's cybersecurity skills will participate in the event and learn some new skills. All right, so let's dive into today's challenge. All right, so what we need to do, looks like I need to turn on my mouse highlighter so that everybody knows what I'm pointing at. Let me do that right now. All right, that's better. Okay, so everybody, the first thing we need to do in today's task is to start our machine because we'll be using it in just a few minutes. So this button is going to start our, is going to spin up our virtual machine that we'll be using for today's challenge. And that's going to split the browser pane in two. The left-hand side is going to have the TryHackMe webpage, and the right-hand side is going to have the virtual machine that we're going to be using to work on today's tasks. So while that initializes, it's going to take, looks like 3 minutes. Let's go back down to the task description and learn about what we're going to be covering today. All right, so over the past few weeks, the Best Festival Company employees have been receiving an excessive number of spam emails. These emails are trying to lure users into the trap of clicking on links and providing credentials. Spam emails are somehow ending up in the mailbox. It looks like the spam detector in place since before the merger has been disabled/damaged deliberately. Suspicion is on McCready, who is not so happy with the merger. Okay, so the problem here is McSkitty has been tasked with building a spam email detector using machine learning, or ML. She has been provided with a sample dataset collected from different sources to train the machine learning model. So what are we going to be learning today? So our learning objectives for the day are, in this task, we'll explore different steps in a generic machine learning pipeline, machine learning classification and training models, how to split the dataset into training and testing data, how to prepare the machine learning model, and how to evaluate the model's effectiveness. So for today's exercise, we do need to start a VM, and there is split screen available. However, after the machine initializes over here, we're going to be putting it in its own separate web browser tab, and we're going to be working inside the virtual machine in its own full screen tab, so that we're better able to see what's going on there. So today we're going to be dealing with Jupyter Notebooks. So what are Jupyter Notebooks? Well, they provide an environment where you can write and execute code in real time, making it ideal for data analysis, machine learning, and scientific research. In this room, we will perform the practical portion on the Jupyter Notebook. Okay, so here's an illustration of what the Jupyter Notebook is going to look like when it's deployed. It's important to recall that we need to run the code from the cells using the Run button or by pressing the shortcut Shift-Enter. Each step is explained on the Jupyter Notebook for better understanding. Let's dive into the details. So, exploring the machine learning pipeline. A machine learning pipeline refers to a series of steps involved in building and deploying an ML model. These steps ensure that data flows effectively from its raw form to predictions and insights. A typical pipeline would include collecting data from different sources in different forms, pre-processing it, and performing feature extraction from the data, splitting the data into testing and training data, and then applying machine learning models and predictions. So we see here in this little illustration, there's ingestion, cleaning, pre-processing, modeling, and deployment. Okay, so the first thing we're going to do is step 0, which is importing the required libraries. Before starting with data collection, we will import the required libraries. Jupyter Notebook comes with all the libraries we need for machine learning. Here we are importing two key libraries, NumPy and Pandas. These libraries are already explained in detail in the previous task. Okay, so here we see that there's some code that imports, there's some Python code here that imports NumPy as an alias over here and Pandas as an alias. Okay, so everybody, now that our machine has finished initializing, we're going to put it in its own tab by pressing this button right here, which is View in Full Screen. So click on that. And our virtual machine will be presented in full screen, just like this. Okay, so here I think we can zoom in on the page. And that makes it a little easier for us to see what's going on. Maybe we can go a little bit bigger still. Okay, so let's increase the magnification a little bit more. And maybe one more step. Okay, so if the text starts looking really weird, we'll turn the magnification down. But for now, let's keep it like this. So on the other page, on the web page, what we can do is we can close out this portion of the browser pane by clicking on this button right here, which is Exit Split View. So it's located down at the bottom and over here. So click on that, and we'll navigate back down. Over here, we were at step 0. Okay, so in actuality, we can work through all of this inside of the virtual machine over here. And what we can do is I think we can drag. We might be able to close this out, this window right here. Let's see if we can. I wonder if we can do it. Okay, so we'll work with this stuff on the screen, but hopefully the text is large enough that you can read it. Okay, so remember that that for each one of these blocks right here, we're gonna have to click on the Run button here to go from one to the other. All right, so we can. So before starting with data collection, we'll import the required libraries. Okay, so we're going to use NumPy, which is numerical Python. It's a fundamental package for numerical computations in Python, as well as Pandas. So Pandas provides high-level data structure and methods designed to make data analysis fast and easy in Python. It's built on top of NumPy. Okay, so we're going to make this a little bit smaller because it's starting to get really cramped. Okay, so that's a little better. All right. So remember, for each one of these, we have to click on the Run button to advance it. Otherwise, the code over here isn't going to run. And we need the code to run in order to go through the exercise properly. Okay, so step 1 is data collection. Data collection is the process of gathering raw data from various sources to be used for machine learning. This data can originate from numerous sources such as databases, text files, APIs, online repositories, sensors, surveys, web scraping, and many others. Here we are using the Pandas library to load the data collected from various sources in the CSV format. The dataset contains spam and ham, non-spam, emails. Okay, so press Run. So in this data block, we're going to set a variable for reading the email data set file over here. So click run on that. So test check dataset. Okay, let's review the dataset that we just imported. The category column contains the email classification, and the message column contains the email body, as shown below. Okay, so if we print the data variable and just I guess just the head, which is just the first beginning portion of it, we get this right here. So we see that there's an ID number and there's a classification, whether this is a spam email or a ham email, and then the content, the body of the message. So data frames provides a structured and tabular representation of data that's intuitive and easy to read. Using the command below, let's use the pandas library to convert the data into a frame. This will make the data easy to analyze and manipulate. All right, so we're going to convert this data into a data frame using this method right here. Okay, and step 2. Let's take a look at step 2, which is data preprocessing. Data preprocessing refers to the techniques used to convert raw data into clean, organized, understandable, and structured format suitable for machine learning. Given that the raw data is often messy, inconsistent, and incomplete, preprocessing is an essential step to ensuring that the data feeding into the ML model is relevant and of high quality. There are several data preprocessing machine learning models, each has their own ways to process the data. Okay? So here we learn about utilizing count vectorizer. So machine learning models understand numbers, not text. This means that the text needs to be transformed into a numerical format. Count vectorizer, a class provided by the scikit-learn library in Python, achieves this by converting text into a token word count matrix. It is used to prepare the data for machine learning models to use and predict decisions on. Here we are using count vectorizer, which is used to extract features from the text. Okay, so we're going to run this code right here. We're going to okay, so this is the line that we're going to use to import this particular function here, count vectorizer. All right. We will now use the count vectorizer function to transform the message column into a numeric as shown below. Okay, so we're going to convert the message column into a numeric with this code right here. And then we're going to print what we just processed. Okay, so some lovely data. Nice. Okay, so the next step we need to do is we need to train and test the split data set. It's important to test the model's performance on unseen data. By splitting the data, we can train our model on one subset and test its performance on another. Here, the variable x contains the data set. We will use the functions from sklearn library to split the data set into training data and testing data as shown below. All right, so the next step is we're going to import some more functions right here, train, test, split from this particular library. And then we're going to split up the df list, it looks like, into different subsets. Xtrain, xtest, ytrain, ytest. Okay. So x, the first argument to train, test, split is the feature matrix x, which we obtained from the count vectorizer. This matrix contains the token counts for each message in the dataset. Y is the second argument is the labels for each instance in the subset, which indicates whether a message is spam or ham. Okay, and this this argument right here, test size equals 0.2. The argument specifies that 20% of the data set should be kept as the test set, and the rest, 80%, should be used for training. It is a common practice to hold out a portion of the data set for testing to evaluate the performance of the model on unseen data. This is where the actual splitting of data into training and test sets happens. The function then returns 4 values: xtrain, the subset of the features to be used for training; xtest, the subset of the features to be used for testing; ytrain, the corresponding labels for the xtrain set; and ytest, the corresponding labels for the xtest set. Okay, so we've come to step 4, model training using naive Bayes. Naive Bayes is a statistical method that uses the probability of certain words appearing in spam and non-spam emails to determine whether a new email is spam or not. So how does naive Bayes classification work? Let's say we have a bunch of emails, some labeled as spam and others as ham. The naive Bayes algorithm learns from these emails. It looks at the words in each email and calculates how frequently each word appears in spam or ham emails. For instance, words like free, win, offer, and lottery might appear more in spam emails. The naive Bayes algorithm calculates the probability of the email being spam based on the words it contains. When the model is trained with naive Bayes and gets a new email that says, for example, win a free toy now, then it thinks win often appears in spam. So this increases the chance of the email being spam. Free is also common in spam, further increasing the spam probability. Toy might be neutral, often appearing in both spam and ham. After considering all the words, it calculates the overall probability of the email being spam and ham. If the calculated probability of spam is higher than that of ham, the algorithm classifies the email as spam. Otherwise, it's classified as ham. Let's use naive Bayes to train the model as shown and explained below. All right, so we of course, when we're running through all of this, we need to click on the run button. Otherwise, the code is not being run and we're not going to be able to get the results we want. So from the sklearn naive Bayes library, we're going to import this particular function, multi-nominal MB, okay, and then we're going to turn this into a variable, and then we're going to train with these arguments right here. Okay, we click on that. So xtrain, this is the training data that you want the model to learn from. It's the token counts for each message in the training data set obtained from the count vectorizer. And ytrain, these are the correct labels, either spam or ham, for each message in the xtrain data set. So this is where the actual training of the model happens. The fit method is used to train or fit the model on your training data. All right, now we go to step 5, which is model evaluation. After training, it's essential to evaluate the model's performance on the test set to gauge its predictive power. This will give you metrics such as accuracy, precision, and recall. So we see here that we're importing yet another function from the sklearn library over here. All right, so we see here that y prediction is this method right here, predict on xtest, and it's going to print the classification report on these 2 arguments here. Okay, so we run that, and we get all of this lovely statistical stuff right here. All right, so the classification report function takes in the true labels ytest and the predictive labels ypred, and returns a text report showing the main classification metrics. The report gives you insights into how well your model is performing for each class and overall in terms of these metrics. So precision. It is the ratio of correctly predicted positive observations to the total predicted positives. The question it answers is, of all the samples predicted as positive, how many were actually positive? Next is recall, otherwise known as sensitivity. It is the ratio of correctly predicted positive observations to all the actual positives. The question it answers is, of all the actual positive samples, how many did we predict correctly? The next is the F1 score. It's the harmonic mean of precision and recall, and it gives a better measure of the incorrectly classified cases than the accuracy metric, especially when there's an imbalance between classes. Support. This is a number of actual occurrences of the class in the specified dataset. Accuracy, it is the ratio of correctly predicted observations to the total observations. The macro average, this averages the unweighted mean per label. And the weighted average, this averages the support weighted mean per label. All right, so we run that. The report gives us insights into how well your model is performing for each class and overall in terms of these metrics. Okay, we've come to step 6. Testing the model. Once satisfied with the model's performance, we can use it to classify new messages and determine if they are spam or ham. Okay, so we're going to take this variable right here, and which is going to transform this email over here, and it's going to predict whether or not the email is spam or ham. All right, so we click on that, and it says that the email is spam. So today's offer. So offer, claim, discount, and voucher. These are all probably words that will get your email flagged as spam. Okay, so great work. We have just completed one cycle of the machine learning pipeline, leaving behind deployment. Okay. So McSkitty has provided us with the latest email messages and asked us to test our model on these emails. Let's run our model on some test emails and see if it can detect spam emails. Okay, so update the following code to include the test emails file and run the trained model against these emails. All right, so what we need to do here, so we're gonna run that. What we need to do here is we need to edit this so that it includes the spam emails. So this, let's see if we can get the full file name for this. So the full file name for the test emails is testemails.csv. So we need to edit this code over here. So we're going to highlight all this, and we're going to replace this with test_emails.csv. Okay, and we're going to run this. And then we're going to print the header of this, let's see, data.head. Okay. So this is going to print the header of this, I assume it's this file right here, testemails.csv. Okay, then we're going to transform the messages into, into numbers. And then we're going to run a prediction against, we're going to run a prediction on this data. And then we're going to get a data frame that shows us whether or not these messages have been flagged as spam or ham. Okay, so we see here that the prediction was that of this list of messages, most of these have been flagged as ham, and 1, 2, 3 of these messages have been flagged as spam. Once you have run the model against the test emails, move on to the task to complete your answers. Okay, so we're going to go back to our original TryHackMe webpage in just a minute. But before that, let's take a look at our conclusion. So that's it from this is it from the task. From the practical point of view, we have to consider the following points to ensure the effectiveness and reliability of our model. We have to continuously monitor the model's performance on a test data set and in a real-life environment. Collect feedback from the end users regarding false positives. Use this feedback to understand the model's weaknesses and areas for improvement, and then we have to deploy the model into production. Okay, so now that we've done our analysis on this list of emails, let's go back to the TryHackMe page and answer the questions for today's challenge. Okay, we can skip all of this because if you have some free time, you can go over this to better understand what is going on in today's challenge. But what we're going to do is we're going to answer the questions at the bottom of the challenge page. Okay, and the first question is, what is the key first step in the machine learning pipeline? So if you remember from the literature that we went over earlier, it is data collection. Okay, the next question is, which data preprocessing feature is used to create new features or modify existing ones to improve model performance? All right, so the answer for this is feature engineering. In actuality, some of these answers are actually obtained in the information portion of today's task. Unfortunately, we don't really have time to go through all of this, and it would be a bit tedious listening to me just read all of this out. So we're going to just skip all that and go down to completing the questions over here. So during the data splitting step, 20% of the data set was split for testing. What is the percentage of the weighted average of the precision spam detection? Okay, so we can get the answer for this by going back to our Jupyter notebook, and we take a look at the model evaluation portion over here. So we're looking at the weighted average, and the weighted average precision, which is what we're looking for, is 0.98. So that's what we can use for the answer here. So we go back, and it's 0.98. And how many of the test emails are marked as spam? If we remember, well, we don't need to remember. We can actually take a look. And we took a look at the model set, and we see out of all the emails here, it predicted that 1, 2, 3 of these emails were marked as spam. So we can answer 3. And lastly, one of the emails that is detected as spam contains a secret code. What is the code? All right, so we can go back to our virtual machine, and we can actually close out our web browser tab by clicking on this button right here. And then we're going to open up our terminal, and we're going to make our terminal nice and big. Okay, if we take a look inside of our home directory, there's a notebooks directory in here. So we can go inside this directory, and we can see that the 3 files that we've been using are listed here. What we want to do is we want to cat out the test emails, and then we're going to grep for the word code, and it should give us the answer that we're looking for. Okay, so this is the email that contains the code, and the secret code is "I hate best festival." So we can highlight this, and then Control-Shift-C to copy it, and then we go back to the page, our web page here, and we can paste it in, and we can submit as the answer. All right, so that's about it for today's challenge. We're just going to click completed on this, just to be thorough and to finish it off. All right, so today we learned about machine learning and the different processes that we perform in machine learning, and then we use the machine learning algorithm, and we ran it against a number of emails and identified which ones were spam and which ones were not spam. All right, so this was all very new to me. I hope everybody learned something today. I know I did. Tomorrow we're going to be working on the next advent of Cyber Challenge. But until then, everybody have a great day, and we will see you next time.